about quadratic functions, we are talking about equations that have an x squared. That is what makes it a quadratic. We've talked about in the past, we talked about linear. Y equals mx plus or minus b, that was linear. We talked about y equals ab to the x. This was exponential. Okay, quadratics are going to be y equals x squared kind of functions. Okay, these are, this is our parent function, and we'll talk about that as we go through this unit. There is a ton of vocabulary here, and if you do not know this vocabulary, it's going to make life really, really hard. A quadratic is going to make this U-shaped graph. This one happens to be going down. Sometimes it will be going up. We've seen that. This is actually called a parabola. Okay, P-A-R-A-B-O-L-A. It's kind of spelled like a disease, right? We want to call it a parabola, but it is a parabola. There are multiple pieces for this. A parabola always has an axis of symmetry. So if you think way back when you learned about symmetry, I think that's a 4th grade topic, means if I was to fold this, it would match up identical, right? So our axis of symmetry, you can see, is always going to be an x equals equation because it will always be a vertical line. At the top of the parabola, where it changes direction, we have what is called the vertex. We've talked about vertex before, that HK, when we talked about shifting, so we're going to revisit that. Notice here, vertex, HK, axis of symmetry, x equals h. So those numbers are going to be the same. Let me go back. Okay, does everybody see that? We can have 2 types of vertexes. We can have a maximum, meaning it's at the top, or a minimum, meaning it's at the bottom. And we're going to talk about how you can tell which is which. Yes. Then it's not quadratic. Buddy points, guys, because we are splitting this in 2, you're going to have points that match up on either side. Those are called buddy points. And then this is the super duper big one. Root solutions, X-intercepts, or zeros. You've actually heard this word zeros before. We did that when we did characteristics of graphs. These are all synonyms. They all mean X-intercept. Now, keep in mind, a quadratic function can have 2, 1, or 0 roots, solutions, x-intercepts, zeros. And you're going to hear me say all 4 of those words over and over and over so that you get used to hearing them. Okay? Yes? All right, any questions so far? So when you look at this first picture, I want you to notice there are only dots here. What does that mean about this information? Is it continuous or discrete? Good, let's make a note. This is discrete data, right? Because there are dots. And if you notice down here, as we go through and we fill out all this information, it does talk about domain. Since it's discrete, our domain is going to be a list. Okay, so there will be some mixed review out through this. We're going to make a little table. Okay, and we're going to see what we can find out. So what is this first coordinate? 0 what? Count again. 0, 5. And we'll just go down. Then we have 1, 0. We have 2, negative 3. All I'm doing is taking the coordinates off of this. This is 3, 1, 2, 3, 4, 3, negative 4. And then look, it's going back up. So 4, negative 3. Notice, do you see how it's going back up? So this should be 2, 3, 4, 5, 0. And going back to 6, 5. When you write out a table for a quadratic, you're going to see that happen. What goes up must come down, or what goes down must come up. So things to keep in mind. This is your y-intercept, right? We've talked about y-intercepts before, and you're going to find that when we write our equation, this is going to be our C value, right? Remember when we were doing our cross puzzle, A, B, and C? That's going to be our C. Other things to keep in mind. What is happening here? We're crossing the x-axis. What is this called? These are called zeros. Give me another word. It's right here if you're not sure. It's a root. What else? X-intercept. What else? Solution. So I can even mark it here. They're technically buddy points, but these are going to be our x-intercept, 0, solution, root. Okay? So we can actually write those here, 1, 0, and 5, 0. This particular quadratic happens to have 2 roots. They won't all. All right, what else do we have on here? I want you to notice we have buddy points here and here, here and here, here and here. This one does not have a buddy point. If it doesn't have a buddy point, this is going to be our vertex, our HK, because it doesn't have a buddy point, okay? This is where it changes direction, meaning the parabola. So this coordinate, 3, -4, that is our vertex. We can draw our symmetrical line through here, our axis of symmetry. That will go through our vertex, because if I was to take and fold my parabola, those buddy points are going to match up. Do you see that? So we can write, this is a vertical equation, x equals, and what number did we cross? 1, 2, 3. We also on the front talked about this is our H in our HK. Okay? Give me a set of buddy points that we see. 6, 5, good, and 0, 5. Very nice. You could write 2, -3, and 4, -3. You could even write your roots again. Now, we talked about vertex is either a maximum or a minimum. If it's a maximum, it's the highest point. If it's a minimum, it's the lowest point. What do you think here? This is a minimum. Okay. What's the y-intercept? 0, 5. We already noticed that. Okay. We talked about min and max values a long time ago when we did characteristics of graphs. A min or a max value is going to be your high or your low y value. So when you look at your table, what is our highest or our lowest y value? Only looking at the y column. This one happens to be -4 because this would technically keep going up. So I want you to make a little note. This is actually going to be your K in your vertex. Okay? So, and it's just going to be Y. We're not going to write Y or anything like that. We're just going to write that value. Okay? So you can make yourself a little note. This is the value only. All right, concavity. This is how the parabola opens. Does this open up or does it open down? It opens up. So concavity up. That is simple. Right? So think of a spoon, right? A spoon is concave versus convex. All right? Kind of like medical terms. All right, your domain, we said, is a list. Is domain X or is domain Y? Domain is X. So I'm going to come back up here. What am I going to write for my X values? Yeah, we're going to write 0, 1, 2, 3, 4, 5, and 6. Remember on domain and range, we don't write any repeat values, and if it was a continuous, we would have inequalities. We'll look at one of those. All right, you need your calculator for this next piece, your quadratic regression. This is list and spreadsheet, so put that in there real quick. A while back, we did list and spreadsheets to write equations. We're going to do the same thing. So we're going to go up and we're going to put in our X and our Y. Some of you learned that if you don't put that first, you are not going to be successful. Okay? All right, so then we're going to put in our X values, 0, 1, 2, 3, 4, 5, 6. Go back up. 5, 0, -3, -4, -3, 0, and 5. And then we're going to go over here to C1. Are we remembering these steps? So remember, when you go to cell C1, you do not want to have a cursor blinking in it. If you do, it's not going to work. You need it to be blue. And we're going to do menu 4, 1. That's where we've had to change. We started with linear. We started with 3, mx plus b. Then we went to exponential. But what kind of regression is this? This is a quadratic, so you're going to go to number 6. So menu 4, 1, 6, and then you just put in your X, down arrow, Y, hit enter twice. Okay, so we can make a little note here. Menu 4, 1, 6. If you look at your calculator, it's going to give us our A, our B, and our C. And if you look here, I'm going to highlight this. You can see it down here. AX squared plus BX plus C. That is the format that we write our quadratics in. So our A is 1. Do we need to write the 1? You can. You don't need to. You can write the 1 if you want. You can just write X squared. Our B is a -6, so -6x. And our C was 5. And do you remember me telling you way up here that the Y-intercept would be our C? What was our Y-intercept? 5. What's our C? 5. Okay? We can factor this. We can do this with cross puzzles. If we did a cross puzzle, I'm just going to do one down here real quick. AC is 5, B is -6. What's it going to be? The sign's the same or different? They are different, really? These are the same. They're both negative, though. What are my factors of 5 that give me 6? 1 and 5. So look, my factored form, y equals x minus 1 times x minus 5, right? We've done that. We just took a test over it. What I want to elaborate on is if I take these factors, x minus 1, and I set them equal to 0. So essentially I'm saying y is 0. I get x equals 1 and x equals 5, right? Do you see x equals 1 and x equals 5 anywhere on our parabola or on our table? Look right here. Y is 0, x is 1, y is 0, x is 5. What were those called?
Buddy.
They are buddy points, but they're also more specifically what? X-intercepts. So you can take those factors that we did in our last unit and you can find your roots. Now, let me talk to you about vertex form, HK. This is on your formula chart. It is in this format, and we will practice this. A parentheses x minus h quantity squared plus k. Do you remember the shifts insiders lie? That's all this is. So this is our format. We already have A. A is 1. We can write the 1 if we want. X minus, what was my h? What was my vertex? Remember, vertex, this is my HK. So minus 3. Quantity squared because it is a quadratic. What was my k? -4. So when we talked about this way back when, we talked about shifts. We said, what does this mean? Well, insiders lie. Is this left or right 3? Insiders lie. This is right 3. What did this -4 mean? Down 4. All right, so I want you to look. You have that written down? So if I go back to my calculator, remember when we do lists and spreadsheets, it saves it in the graph for us. Do you remember that? Everybody do this. Follow my lead. Control Doc. We're going to add a graph. Remember, it's at 2 because what did it put in 1? It put our equation. Use your up arrow. Look, there's our equation. It just didn't round it to a whole number, but that's okay. We can hit enter. Oh, look how pretty that is. It matches our picture, doesn't it? Control Doc 2. So if I put tab and I said, okay, my parent function is x squared. We're going to do some more with that. I want you to look and see what happens here. What did it do? Did it go left or right? From the parent function, it went 3 to the right and 4 down. So this is going to tie back into what we did originally. All right. Shall we try one more? Too bad. All right, let's do this. Is this continuous or discrete? All right, make a note. That means we're going to use inequalities when we do our domain and range. I want you to take a minute and I want you to put your coordinates in the table. Now, you don't have to put all of them. That's okay. If you just want to put these 5, that's fine. So take a moment and fill out the table. All right, so here's what you should have for your table. From this and from the picture, you need to be able to pick out all of those key pieces we discussed. Is there a root, a 0, x-intercept, or solution? What is it? -6, 0 right here, and -2, 0. Okay, notice those, we have all of these buddy points, except for here, what is this one called? That is called your vertex, right? That's your HK. We can write that here. -4, -4. All right, you could label this roots, solution. I'm going to write my x-intercept here, and 0. You need to know all 3 of those names. Okay, this is our vertex. What kind of vertex is this? It is a minimum. It's at the bottom. Good job. If I was to draw my axis of symmetry, what would be my equation for this? It's a vertical line. So it's going to be x equals, what is it going through on the x-axis? -4. Remember, it matches the x value of your vertex, always. Can you give me some buddy points? There's several. Just give me one set. -7, 5, and -1, 5. You could have said -5, -3, and -3, -3 also. Okay, do we have a y-intercept? Not on the graph. There is one. Remember, in our equation, what letter is it? It is C. So let's just make a little note. This is going to be our C. So when we write our equation, we'll be able to fill that in. We said it's a minimum, right? So what's our minimum value? -4. Good. Remember, it is from, this is the x value of the vertex. This is the y value of the vertex. What is our equation for our parent function? We wrote it on the front. Y equals that this is going to be the equation we compare all quadratics to. It is y equals x squared. The range is going to be written with inequalities. We just said up here this was continuous. So if this is my lowest y value, what was it? -4. How am I going to write that? -4 is less than or equal to y. Good job. You could flip it around. You can say y is greater than or equal to -4. Either way. I want you to use your calculator. We have just a few minutes. Use your calculator. Put your table in there. Let's see if we can't get our... You should have 1x squared plus 8x plus 12 when you use your calculator. So y equals 1x squared plus 8x plus 12. So what else can we fill in that we have this now? What's the y-intercept? 0, 12. It is a coordinate. We can do vertex form, right? It's just our hk. So let's write it a parentheses x minus h quantity squared plus k. So a is 1. We just got that on our previous. We don't have to write it. X minus, what was h? What was our axis of symmetry, our x value on our vertex? So minus a -4 becomes a +4 quantity squared. What's our k? -4. I am going to ask you, I want you to write the factored form for me tonight, and I want you to compare it to the parent function, and we will do number 3 tomorrow. If you think you can start number 3, by all means. Otherwise, we'll visit tomorrow. Good job today.